And what I'm about to show you now, which is a very rapidly growing success story, I can say would not be in the same position without Kenny and the Bioneers movement that gave me a forum to talk to the world at large. And I really thank Kenny for his encouragement and support over the years. And thank you, Christine Lowe, for inviting me to this excellent forum. And I really am delighted by the professionalism and excellence that I'm seeing in Hong Kong and China. And I used to come here quite a lot from Australia, but I haven't been here for 20 years, so this is very refreshing for me. I've been at the coalface in America trying to get these messages across in the United States. So yesterday and today we've heard a lot about the problems of the Earth. And, you know, when I attend conferences like this, it's very easy to kind of slump and say, wow, I think we're really going down the drain. And it's hard to imagine how we can pull ourselves out of these dilemmas when we have failures at Kyoto and Copenhagen and so forth. So perhaps the biggest challenge we have, and we probably all recognize, is global warming. Global warming is a product, largely, we all believe, from the burning of fossil fuels. And what I would ask is, why are we using all of these fossil fuels? What are we using energy for? And I brought this little bucket along. I'm going to show you some images in a moment. We're developing more and more technologies for exploiting harder and harder to get fossil fuels that are more and more polluting, like tar sands in Canada. We're digging up more coal. We're increasing our rate of consumption of these things at a prodigious rate. And we're putting all of this fuel, all of this carbon, into this bucket of consumption of energy, if you like. And here is a major problem. If we look at the bottom of the bucket, it's full of holes. We waste an enormous amount of energy. And yesterday somebody asked, is there a silver bullet to solving the world's global warming issues? And you know, I'm going to show you at least one silver bullet. And I think this is a very comprehensive opportunity and possibility. And I wonder if we could start the DVD. I'm going to show you a film that just lasts a couple of minutes.
Most people think of nature's movements as chaotic, but there is a common shape underlying all of that chaos. This shape has been well known throughout human history.
Could we have more volume, please?
Early civilizations recognized that spiral shapes are common in nature and often used them as representations of creation, fertility, and divinity. In fact, the spiral is one of the most common symbols found throughout all ancient cultures. Now, with the benefit of modern science, we can see that these spirals are everywhere, from the zipping and unzipping of DNA to particle decay and quantum physics, to the growth patterns of every living thing, leaves, animal horns, sap veins in trees, seashells and rose petals. We used to believe the world was flat. We thought the sun went around the earth. We even thought that the stars were gods and heroes, until we became aware of the natural laws of physics and chemistry that govern our universe as it spirals through space. What other discoveries can we make if we look deeply into nature? What solutions to the growing energy crisis are available to scientists and engineers who look with a new set of eyes? By observing natural fluid flow in all of its forms, we know that from the atomic level to the very largest structures in our universe, movement tends to follow the same path as the whirlpool you see when you pull the plug in your bathtub. This is the path of least resistance. If we want to use less or produce more energy, then we need to follow this path.
Thank you. You know, the world of science and technology has come to the conclusion over the last 300 years that if you want to use the least energy, you need to travel in a straight line, which sounds absolutely reasonable. Any engineers and physicists here would absolutely agree with that. So we tend to build all of our pipes and the sides of aircraft in straight lines. We want water and air to go in a straight path, the shortest distance between 2 points. The interesting thing is that nature never uses a straight path. There's not a single example of that anywhere in nature. And if we look at the human cardiovascular system, for instance, we have 60,000 miles of plumbing in our bodies, and there's not a straight line in there. And yet the heart and the cardiovascular system is incredibly efficient. So nature's doing something there that is a surprise, if you like. It's not using straight lines, but in many cases, it's using half or even much less energy than human technologies. You know, even the ordinary housefly, any insect, there's not a scientist in the world today that can explain the flight efficiency of a single insect. If we could capture that information and apply it to aircraft and other designs, we could really reduce our energy bill. So let's have a look at this. When I was a boy, as Kenny said, I grew up beside the ocean, and I looked at seaweeds. And these seaweeds all change their shape to a common geometry when waves go past. So even the most violent storms don't destroy the weeds, which you could normally break off quite easily. And this kind of looks like the logo for Hong Kong, which I saw yesterday was very interesting. But that flow path that we see in the seaweed is exactly the same as the whirlpool that you see in a bathtub when you pull the plug from the drain, and that's it on the left there. And when I was a boy, I noticed that, wow, seashells are built the same way, and they're essentially the same geometry. And firestorms, heat travels the same way. When you light a candle, the smoke comes off in these same spirals. Even sap in a tree, or every single plant, the sap is coming up the plant in this same geometric flow, this spiral. And a redwood tree can pump water 330 feet above the ground without a pump using this process. We see it right through the animal kingdom. In fact, every living thing goes through a liquid phase in its development. So it takes on the geometry of water flow. So every part of every living being is designed according to the geometry of a single whirlpool. Now we can see the obvious expressions of this here, but even your eyelashes, if you kept growing them, will turn into these spirals. Our fingernails do. Our bones grow this way. This is an electron microscope photograph of a human skin pore. This is how we perspire. The human heart, that wonderfully efficient pump, is a spiral muscle that is mimicking exactly the whirlpool in your bathtub. Here we have, on the right, a seashell, on the left, the cochlea of our ear. It looks exactly the same. We hear through the same system. When we breathe in and out, we're breathing exactly the same way. Our veins in our bloodstream, exactly the same. And we see it in plants. There's the inner part of a cochlea, and there's a palm tree and a Christmas worm from the ocean. Seashell on the left, and here is a DNA molecule. It's actually not a helix. It's not a parallel-sided helix, because nature doesn't do parallel sides. It's actually logarithmic. So I'm asked, well, what about a diamond? You know, surely there are straight things in nature, the side of a salt crystal. Well, actually not under an electron microscope. No such thing as a straight line anywhere in our universe. So people have looked at this for millennia. They've seen these spirals, And they took a cross-section of these spirals, and they saw that this line represents a two-dimensional slice through a whirlpool. And that was used as the geometry, or the underlying math, to create the world's most beautiful buildings. All over the world, the buildings that we treasure the most, starting with the pyramids 5,000 years ago, right through to the White House today, are all built according to the geometries of that whirlpool.